All right, so welcome to the May 2025 Minnesota Astronomical Society monthly meeting. My name is Waltz Treybergs. I'm president. And so basically, we've got a pretty full agenda for today. So I'll introduce the board as I normally do, and we'll have a membership update. And I'll go over the next following month's astronomical events. And then NOHA will present the treasurer's report for as end of April 2025. And then we have a special member presentation from Jeff Ballard and some PSAs and some AL announcements. And then we will have our featured speaker, Chuck Allen from the Astronomical League. So that is what we're doing while we're looking at a picture of the M104 Sombrero Galaxy that Conrad Sanders took last week. And I do want to point out, this is a picture that Chris Bethia took up at LLCC last Friday. Just gorgeous, gorgeous shot right off a Long Lake. All right, here's our board. I do believe that we are a complete crew here. So board members, raise your hand. Like I said, I'm Waltz, John Zimmich, VP, Claire Weaverling, Secretary, Noha, Reda, Treasurer, and Jesse and Phil are members at large. Any questions about the board? Any way, if you want to contact anybody at the board or the entire board, mnastro.org about board contacts on that webpage. There's a contact form. You can contact any or all of us at any time. So membership. So we are currently at 742 total members, 3 honorary, 166 patron members, 538 regular, 35 student as of today, according to Steve. New members. So any new members here on either online or physically here in the room? None? Okay. And then we also welcome back a couple returning members as well. As usual, if there's any membership type questions, reach out to Steve at membership@mnastro.org. Astro events. So seems like May is kind of a boring month, but there's a few things going on. May 2nd, tomorrow, Vesta will be out of opposition. Conjunction of Moon and Mars on the 3rd. First quarter moon, May 4th. Eta Aquariid meteor shower peaks, May 5th. Saturn will be at equinox, May 6th. Eta Lyrid meteor shower peaks at May 8th. Full moon, May 12th. Last quarter moon, May 20th. Conjunction moon and Saturn around May 22nd. New moon, May 26th. Venus at greatest elongation west, May 31st. And then June 4th, which is right before our next meeting, conjunction of Venus and Eris, if you really want to get out and try that. Yeah. Try to get that one. All right. Me being a space nerd, I've always followed along with the space missions. May 6th, Japan's Hakuto R lunar lander will do its lunar orbit insertion. That's the schedule right now. And then May 9th or 10th, no one really knows for sure, but Cosmos 482 is predicted to re-enter Earth's atmosphere. So this is an interesting craft. It's actually a Soviet-era Venus lander that never made it out of Earth's orbit. So interesting enough, it's got a heat shield. It was designed to land on Venus. So if it can land on Venus, it might actually stay in the Earth's atmosphere and actually make it to the ground in one piece. So we'll see where that goes. Yeah. All right. ULA is planning on launching their Vulcan Centaur rocket. And then the Chinese Tianwen-2 asteroid sample return mission is launching to Kamo'olaua. So the Chinese are also launching a asteroid sample return mission, which is really cool. So for these kind of events, again, I pulled most of this stuff from inthesky.org, and there's a lot of other resources around there available. All right, what else is going on? MAS events tomorrow night. Planets in the Park. So I really like to highlight this one. Michael Copper does a great job at this. This is a really a great urban astronomy outreach event. It is tomorrow, 8:30 to 10 at Pershing Park in South Minneapolis, 3523 West 48th Street. And as usual, Michael welcomes any visitors and any volunteers with telescopes to help set up. It's a fun time. So that's a great urban outreach event that we support, and canceled only if rainy or stormy. So if Michael, you've got any other comments? If you're online, please jump in. All right. All right. Then Saturday is going to be a very busy day for MAS. So we've got three separate events going on. So first one is Spring Astronomy Day at Eagle Lake Observatory. Everything starts, the activities start at 2 p.m. and go to about 11 p.m. If the sky is open and people are able to observe, it's a free event, open to all. And again, it's at Eagle Lake Observatory in Baylor Park. And we've got a bunch of speakers scheduled. 2 o'clock, Nadia will talk about the NASA Dragonfly mission. 3 o'clock, Laura will talk about a supernova when stars explode. 4 o'clock, John Fisher talks about spectroscopy and what stars are made of. And then at 7 o'clock, Sarah Devine talks about messy science, talking about the Messier catalog. And at 8 o'clock, there's a door prize drawing, and then customarily observing after dark. So we're all proud to participate in that, and the ELO committee is working hard to put all that stuff together, and volunteers are always appreciated for those events. In addition, the Beginner Special Interest Group is also meeting on Saturday on the other side of town, set on May 3rd from 7 p.m., starting at 7 p.m. at Metcalf Field. So this is a venue where you can bring your own scope. If you've got a scope and you don't know how to use it, it's basically you bring your own and you get help from members. They walk you through collimation, they walk you through setup and all that stuff. It's a really fun event. Suresh does a great job describing telescope optics and what they do, and the differences between different types of telescopes, and talks about some of the things that you might see in the sky for that. So there's some galaxies out and some other early summer things that might be popping up over the horizon, over the trees. So there's a sign up form on the beginners area of the website. Suresh, you got anything more to say about the BSIG? All right, welcome. Well, join us. It's a fun time. It's a great event. Really casual, and snack table. Bring snacks if you wish, and bring your telescope and ask questions and get your questions answered. So great event. And we're still not done with Saturday. We've got a public star party also in the north side of town at Cedar Creek, at the Cedar Creek Ecosystem Science Reserve, which is part of the University of Minnesota. So we've got a partnership with them. So this is kind of a more of a casual star party, and there's one presentation usually in the early evening, and we just, whoever shows up, we bring out our telescopes and have about 3 or 4 telescopes looking up at that. So that's on the north side of town. So we've got a lot of different options to do on this Saturday. So yeah, very, very full event. All right, other upcoming events for the month. Already talked about Planets in the Park and Astronomy Day and BSIG and Cedar Creek. There's an ELO Public Star Party Saturday, May 17th. LLCC will have a member observing weekend, May 23rd and 25th. Cherry Grove Member Star Party, Friday, May 23rd, with a backup on Saturday. Then there's another ELO Public Star Party, Saturday, May 31st. And then the next monthly meeting is Thursday, June 5th at 7 p.m. right here. Oh, BSIG May 3rd, yeah. Correct. Did I have it right on their other slide? Okay. All right. And in addition to that, we do have some scheduled key holder training sessions for Eagle Lake Observatory. It's scheduled for May 17th, and the sign up for that is on the website. For JJC, there's the scheduled key holder training is May 10th and the sign up for that is on the MAS forum, as well as the CGO training, which is May 23rd, in conjunction with the CGO Member Star Party, May 23rd. So that's also a forum sign up. And then there's no scheduled LLCC training during May, but that's customarily just done during Northern Night Starfest. So any questions on any upcoming events over the next month? All right, lots going on. Thank you. So one thing that she did highlight is equipment donations, and I noticed that we haven't been thanking the people that actually have been donating equipment. So John Zimmich here put together a nice slide with all the different pieces of all the people that have either donated telescopes, books, eyepieces, or any other ancillary equipment that often we either repurpose to put into an existing observatory, we donate to one of our outreach sites, or we outright sell for income funds. And as Noah you alluded to, we actually had over $1,000 in equipment sales already this year. So, and we've got a lot more equipment on the books that is going to go up for the marketplace. I believe we got some eyepieces. There's some other telescopes coming, and we're just getting those put together. We're also getting telescopes donated and are able to don't use them for our Astronomy Day and Camping with the Stars giveaways as well. So we're actually passing on a couple donations that we received for that very event. So thank you all donors, and if you have any equipment that you would like to donate to MAS, please contact the Vice President at vicepresident@mnastro.org or anybody on the board, and we'd be happy to take a look at it. Like I said, what we normally do for equipment, we'll evaluate it. Does it have value? Does it have a need for it somewhere in the club at one of our observatories? Is it just we turn around and just sell it, or we donate it? So we'll take that. All right. Thank you for that. All right. Volunteers, and this is a repeat from last month. So as most of you know, Lila Scherstein has stepped down as outreach coordinator, and Jesse Palmer has taken over that job as outreach coordinator. And in addition to just having a single outreach coordinator, the board has asked and is trying to put together a larger outreach group to actually have a standing committee that takes on the full responsibility of outreach. So, and then also take outreach to the next level. What kind of options can we do for outreach to make it go smoother, to have it more opportunities for volunteerism, like pushing outreach more into our Slack workspace, looking at other kind of educational materials that we can have in our outreach bins, what kind of promotional literature we can be creating or promoting or passing on to the public. So if you have any interest in joining the official outreach committee, please email info@mnastro.org or outreach@mnastro.org, and we will get in contact with you. At some point during the month of May, the board and the outreach committee is going to get together and kind of put together a formal outline of what we want to achieve for the outreach committee going forward. So please volunteer. It's a fun opportunity. You can volunteer either at tabled events or just do telescopes for Cub Scouts or Boy Scouts or Girl Scouts or whatever kind of private event you can do. We'll do it at our facility, or we'll go out to a public park, or we'll do it at wherever somebody wants to do it if we can find volunteers. Volunteers are always needed for outreach. So thanks for that. All right, member presentations. So as we've been doing for the past few months, we're really trying to get member presentations. So we've got a member presentation from Jeff Ballard. So he's going to be coming up here shortly to do his presentation. But if you have any kind of passion in the hobby, whether you got an observing campaign, whether you're fascinated with some kind of astronomical objects, whether you're into history, astronomical history, or related science history, or you've got some adventures to dark sky areas that you've been to on vacation or on an astronomy related trip, or if you've got a cool amateur telescope making project and you want to do a show and tell, that's an opportunity for that. Do restoration projects like I like to do, or some kind of outreach project that's above and beyond, kind of like what Jeff is doing. We'll talk about here in a little bit. You're doing some research, spectroscopy, anything like that would be pretty interesting. If you want to explore new venues in software, in image processing, any of that it's all open game. So even going into NASA and space missions, robotic missions, old historical missions, that's better. And if you really, really want, I can dig up the old Better Know a Constellation 3-ring binder. It's about 8 pounds now. So I think I'll bring it next month because I think because we don't have a member presentation for next month. So I'm gonna bring the book next month. So I will leave that book with somebody, Chris. I will leave it with Chris Setness. All right. So if you have an idea for a member presentation, it can be a short little thing. It could be 5 slides, 10 slides, really simple 5-10 minute talk or a demonstration. That's all you need. Very, very simple. Contact Ahmed at programs@mnastro.org. So that's where you can get on the calendar and we'll schedule you in. So we really want your presentations. This group is, if you're interested in it, it's likely that everybody else is going to be interested in that topic too. So, member presentation, let me present Jeff Ballard, and he's got a presentation that he calls Analemma Connections. Here, let me give you here. Let me put this on.
Okay. Turn off your cell phone.
Yeah, so just
Right here?
Yep. Nope, nope. That way. Yep. Just over your ear. Put that in your pocket. There you go.
Wow. Okay, I'm Jeff Bullard, and I'm a retired science teacher. First 18 years was in Enid, Oklahoma at Emerson Junior High. And then my wife and I moved up here in 1993, where I taught at Fridley High School until I retired in 2016. But I've continued teaching middle school students at Summer Academy and most recently at Mighty, Minnesota Institute for Talented Youth. And I've been working with Ron back there. We take field trips to the greatest little astronomy clubhouse probably on the planet. If you've not been there, you need to go. So what I was doing in teaching was trying to get students to understand difficult concepts, because let's face it, there's some difficult concepts in astronomy. And what kind of concepts could I explore during the day? That was my question. So I came up with something that I want to share with you today. But first of all, I want to ask you a question. Can you point to the North Pole? Would you try it? By the way, that's a south. Yep. North Pole? Well, you guys are pointing up in space. Did you not know the Earth is round? That this Earth's curves over there? See, that's the deal. That's the deal right there. We know the Earth is round, but how deeply do we know that? Do we think we're driving across the country? Flat map. We're on a curved surface. Okay, which way is this room moving? We're on a planet that moves, right? Point to the direction it's moving. So you guys are the Minnesota Astronomical Society and you don't know this? To the east. how do we get kids to make observations that they know it? Well, that's what I came up with this. These globes, by the way, here's the deal. I was in middle school or high school, I can't remember when, on the desk in front of me when I was in school was a globe, and it's like most globes, it's tilted 23.5 degrees, and I wondered, what's the tabletop in space? What tilted to what? To the ecliptic, of course, right? The Earth's orbital plane, right? But how was that measured? How do we know that? Well, if I could get some volunteers, first of all, we need to set up the model. So if we could get some people here, maybe you guys could work in a group. You need a globe.
Get out there and observe or image.
Yeah, there we go. Oh, what's happening? Oh, here you go. Come on, guys. Somebody come up over here in this area. Want to grab this? We're not gonna throw the Earth. Well, I can do that. All right, here's the deal. When you get your globe, I want you to set it up to model the planet we're standing on. Orient it so it represents
This is a model of Earth.
exactly how the Earth is below our feet. You guys we need a group here. Here you go. Can you guys work in a group? So we kind of gather around. I don't have enough of these for just every table, but maybe one here for you guys. Right there. And all right. So how do we model the Earth under our feet? Well, you just pointed to where is the North Pole? Down there somewhere, right? Okay. So once you get your globe set up like this, we are on, everywhere I go, I feel like I'm top of the Earth. How about you? On top of the world. So orient it so Minneapolis, St. Paul, and the Gulf tee are perpendicular. They wonder the same about us. We have somebody representing a middle school student here, don't we? All right, now next, you want to rotate your planet so that the North Pole of your planet is pointing north. Got it? Now, you can see, where's the North Pole? Right there. Where's Australia? Where are you, Australia? Right there. With me? So now we can actually visualize where places are. And it's not like there's London. There's London. Now, we take it out into sunshine.
This is a model of Earth in space today on the equinox. This model represents the planet I'm standing on right now because I live in Minneapolis, St. Paul. That's where the Gulf tee is. And that direction, the pole of the model, the North Pole, there it is pointing north. So it's a model right now, and you notice where the shadow line is. Look at that. Pole to pole. Today, that's why they call it the equinox. Spinning to the east, everybody spins halfway into darkness, halfway into light.
giving you a view of my garage.
Earth in space.
The next slide shows you
Better shadows. Still lined up. Direct rays. Opposite the shadow. Here they are. Right in the equator.
where are the direct rays striking the planet on
Autumnal equinox.
autumnal equinox. Right, right, and you can visualize that. Now, the next
What
slide.
that has to do
Oh, wait a minute.
with our observations.
What is that? Next slide will show you. Do you have the clicker? Do I have it? Oh, here we go. So here's Summer Academy students determining the direct rays on June 20th. And where do you think they're striking on June 20th? The Tropic of Cancer. That also brings in the question of why is it called Cancer? Zodiac constellations, right? The ecliptic. The sun is behind. Well, not now. We have 13 constellations now, right, in the zodiac, and it's shifted and all that. But that's all subjects that can be brought up with a simple little globe on a tube. Next slide. I think you'll see how I've used various methods to determine where the direct rays are. Here is a stick with a knife holding onto it to try to determine where the direct rays are striking. So that's a no shadow on September 20th. Next slide. What do you have here? Oh, December. Winter solstice. Direct rays striking the Tropic of Capricorn. You can see here that the Arctic Circle is in darkness, and if you looked on the bottom, the Antarctic Circle, which is 23.5 degrees, by the way, from the poles, and 23.5 degrees from the equator, where the Tropic of Cancer and Capricorn are. So there you have it. To try to understand this concept that we have a tilted axis that causes seasons is very abstract. And you could maybe do some virtual things, look at some videos or some things that demonstrate it, but why not be out in the cold and determining where the direct rays are striking, and out in the heat whenever the summer solstice and you're measuring direct rays, you get this feeling that you're actually on a planet, and you're understanding that you were on a planet that orbits the sun on a tilted axis. Next slide. Here's one year I tried this thing that didn't work very well. Cut it out so you can see, put a hole there. The best way to do it is with these little clear plastic tops. This one was a Benadryl. It's clear. It really shows up. You can really see, because the point is you want to keep this perpendicular to it, so you get a direct reading of where the direct rays are striking. So this is something to do throughout the year. I think if you have grandkids, nephews, nieces, anybody, it's like daytime astronomy. That's the deal. It's not just something that happens at night. We're in space all the time. And by the way, we orbit a star, and we can measure and be curious about all kinds of things. Next slide is the analemma. So what's up with this up and down? What does that measure? The tilt. You ask questions. What if the tilt was only 10 degrees to the ecliptic? How would that affect the analemma? Where would the Tropic of Cancer and the Tropic of Capricorn be? Right? Now, what about this equation of time where the clock is behind, here's the clock, it's behind the sun, here's the clock, 24 hours, the clock is ahead of this. What's up with that? The elliptic orbit, Kepler's laws of planetary motion can then be, where are we at perihelion? Closest. Where are we moving fastest? Right? That's the deal. What would happen if the Earth had a circular orbit? How would that affect the analemma? You're right, it'd be up and down, right? There would be no variation. The idea is that a sidereal day is measured by stars. And then we've moved a degree, there's the sun, 24 hours, average, right? But what if I'm moving at a constant speed? Then there's no variation in time. The clock is 24, the sun is 24. But as the Earth moves faster, whoa, there's the sun. So the analemma is kind of like a musical note, the cleft note. It's the harmony of our planet in orbit around the sun. And we can visualize our planet in space with a simple little deal like this. So I hope you'll maybe get your globes off of their tilted axis and out in the sun. Thank you.
Thank you, Jeff. Anybody have any questions for Jeff?
Howard Gardner's multiple intelligence theory, there's all kinds of intelligence, and one of them is musical. So that gave me the license to actually bring my guitar in the classroom and start singing songs, parodies like "Free Falling." I always thought Tom Petty song. I always thought that should be about why astronauts are weightless in Earth orbit. And so I did a whole song about Newton and Galileo climbed Tower of Pisa, dropped objects, see how they'd fall. And next time I'll bring the guitar.
Thanks, Jeff. All right, moving on. Loaner Scope program. So one notice that, so backing up a little bit, the MAS has a very good Loaner Scope program. We've got many telescopes. We've got SCTs, we've got Dobbs, we've got refractors, we've got a solar scope, we've got binoculars, and we also have a full library of great courses available for loan to members. Just to able to request those, you go to the website, membership, Loaner Scope program, and just fill out that form, and then arrange with Anton Gregory in Vadnais Heights, where he lives, for pickup, and you can borrow that equipment for a month or sometimes often more if there's nobody else waiting. So that's a great program. But one thing that Anton advised us is that he is pending a vacation this summer. So scopes have to be picked up by June 7th because he's going to be gone several weeks. So if you do want a Loaner Scope program over that period of time, make that arrangement soon and take care of that before he's away, because there's really no backup for Anton at this point. Yeah, Anton can't take time. I guess we'll have to cancel his vacation. Yeah. Okay, sounds good. All right. What else is going on? So just a few weekly happenings newsletter. So every Tuesday, the secretary, Claire, sends out a MailChimp blast to our over 1,100 subscribers. And I enjoy the content thoroughly. If that's a free resource, and you do not have to be a member to sign up. And all you have to do is go to our website and fill out that form that says stay in touch, or fill out the free newsletter form, and you'll get added to the MailChimp mail blast list. And that goes out every Tuesday. And basically, if there's news to announce, but now since it's observing season, there's pretty much something going on every single week. So you'll get regular Tuesday emails. If you have something to submit for the weekly happenings, please send that to secretary@mnastro.org by Saturday or Friday or Saturday, the Friday night. Friday night, and then Claire will edit that and put it into the happenings and schedule it for delivery on Tuesday. So also on the website, if you want to, the happenings are all archived on the homepage as a blog, so you can go back in history and read up on all of the previous happenings for the last 6 months or so, and that's an ongoing thing. All right. Also, online communities. So we've got several options. We've got member-only Slack. So you have to be a member to subscribe to Slack. Slack gives you a full mobile-friendly chat option. And then there's huddles. You can do real-time communication, and it's really a good forum and modern communication tool. We also have our MN Astro forums. So it's forums@mnastro.org is the website. It's free to sign up. You do not have to be a member to participate in the forums. And in the forums, we have our marketplace. We've got all of our key holder specific topics. We've got a new spectroscopy topic that's Suresh started last month, and some other, and other than the equipment, books, gadgets, all that kind of discussions. And then site-specific topics, sign-ups for Long Lake Conservation Center weekends, sign-ups for key holder training, and all of that stuff. Then, of course, we also have a presence on social media, on Facebook and Instagram, and so follow us on those platforms as well. If you have images that you would like to submit, or any news articles or any events that you want to promote, send that to socialmedia@mnastro.org. We do suggest, if you do have an image that you want to post on as part of the Minnesota Astronomical Society social media platforms, that you watermark the images, and so you get full credit for it. All right, so those are our online communities. So many ways to participate. Mass merchandise still available on Cafe Press, and we still haven't updated some of the things like we've been promising to do, but we will get to that in the next month or two. So, but if you want hats, mugs, shirts, sweatshirts, and that kind of stuff with the Mass branded logo, you can order those as you wish. Okay, Gemini. So Gemini is published 6 times a year. Father Brown does a great job putting that together and keeping us informed. Gemini is one of the few newsletters, club newsletters, that only publishes member content. So we don't republish other content that comes from other sources. It's just all member articles. So you can write about, just like member presentations. If you got a passion, if you got something that you experienced and want to write about it, write us an article, include some pictures, and Father Brown will put it into the next Gemini. He's always looking for articles. So if you want to submit an article, send it to gemini@mnastro.org. And on the website, we've got all of our Gemini history, the full database, every single Gemini going back to before the MAS was MAS, when it was Twin City Astronomy Club. And that archive is fully indexed and fully searchable. So if you're looking for an article from 1975, you just have to search for it and you'll find it. Other public service announcements. There's some free stuff in the back of the room. There's some books. There's an old equatorial mount with an Edmund equatorial head. There's actually a Unitron 60 millimeter refractor available for anyone who wants to take it. It's not complete, but the optics are in good shape, and it is a Unitron. So, and then there's some other lenses and a couple other gadgets back there. So please feel free to take any of that stuff. Also on the Marketplace Forum, we do have a very, very nice Unitron 6414 for sale. It's basically that same refractor, but it's got the full Altaz mount, and it's with the full Altaz tripod and everything, and it's in really, really nice shape. It's a full eyepiece set, a diagonal, everything. So that is for sale on the Marketplace, on the forum, and if you don't like the price, just send us an offer, and we'll probably let you have it for whatever you want for it. All right. Does anyone else have anything to say? Public service announcements. Dean.
Thanks, Walt. I just want to let folks know that there's a Bell Star party tomorrow night. Official start time is 9:30. So, but right now, as far as I can tell, I might be the only volunteer that's signed up to staff our table there. So we can always use a couple more people to help out. It's a fun time. It's obviously easier to talk to more people with more mouths. So if anybody's available tomorrow night, if you can park in the you can park in their lot, and they will validate your parking, so you don't have to pay for that. And otherwise, it's nice to bring your MAS name tag maybe, so people know who you are. But just volunteer if you feel comfortable talking about the club, etc., or astronomy in general. Your presence would be appreciated. Thanks. Thanks, Bert.
Thank you, Dean. And the outreach opportunities are available on the MAS forum. So if you go to if you're a registered forum member, you can go to the outreach section of the forum, and you can see all of the outreach things. So that is one of the things the outreach committee is going to try to do, is try to streamline that process and make it simpler and easier to sign up, and easier to find stuff going forward. So. That all the listed outreach opportunities where volunteers are still needed are still listed on that on the forum. All right. Any other announcements or public service announcements? All right. So, astronomical lead awards and information. So, we don't have Jerry with us tonight, but we have Cartoon Jerry. So I actually had ChatGPT make that for me this morning. So no awards this month. So unfortunately, all we can do is listen to virtual Jerry. Ah, where's virtual Jerry? They worked before. He already spoke. So anyway, get out there and observe. We know. Yes, sir, Ron. Yes, the YouTube. Yeah, I didn't mention on social media, we do have a YouTube channel. So just search for Minnesota Astronomical Society. So all of these meetings are recorded and edited and recorded, and all of the BSIG winter presentations are put on there. So you can get plenty of Jerry. And I think I found one that Jerry did for the Bell Museum as well, which was also very good talk. Alan. Yeah.
Get out there and observe, or image.
Yay. Yay.
Get out there and observe.
One more
or
time.
image.
All right. So one last comment is, so last week we the NCRAL wrapped up their convention out in Minnetonka, and I was unfortunately not able to make that event, any of those events. But we did have a number of volunteers that helped out from MAS at the Eagle Lake Observatory and in a few other venues out there. So Steve, Don, Trina, Mike, Doug, Jesse, Ahmed, Noha, Ron, Suresh, Alan, Claire, John, and Mark. So thank you all, and thank you Chuck Allen and all the other organizers. Oh, Dean. Okay, we'll put on there. Dean on there too. So, anybody else? There's a lot of help, getting that thing going, along with the NCRAL regional leadership. So, it was a great event, and I heard nothing but positive things from the meeting and the event at ELO. So, thank you volunteers for helping out, making that event a successful one. All right, so now I would like to introduce our featured speaker, Chuck Allen. He is the current president of the Astronomical League, and his talk is going to be perspectives on distance. So let's get Chuck a warm round of applause while I get the microphone on him, and we can get his presentation.
Okay, first of all, it's really exciting for me to be here because you have been one of the three largest clubs in the entire league for years. I know all of your activities. I know your city is surrounded by observatories, so that tells me a lot about your activity level. And I've been wanting to get here for a long time. And you've been kind enough to invite me to speak remotely a number of times, I think 4 previous times. And I'm finally excited to be here with a somewhat sketchy voice as a result of some anesthetic from a root canal. So I apologize for that. It was no fun. I've been all over your state in the last few days between NCRAL and here, making it all the way to the northwest angle, no less, which is going to take me a while to get the clay off my car. But kind of interesting trip, and I really enjoyed seeing the North Country a lot. When I was president of the league the first time, we had in the league 18,000 members and a trust fund with $50,000 in it. Now we have 25,000 members and 26 times more money in the trust fund, which is helping us keep dues low because of the investments that we've made using that. And you are responsible for 3% of our membership, which is pretty substantial when you consider there are 310 clubs in the United States. So thank you for your membership and for all you do for your community. Okay, so let's start. We're going to be talking today about perspectives on distance. And just to give you a little way of sensing some of the distances that we talk about so often. And I'm going to start by showing you a picture that was taken in 1965. And it was taken in Milwaukee at the 1965 Astronomical League National Convention. Now, what you may notice here is that amateur astronomers dress differently than they do today. And there were 38 young people in this crowd, 38 high school students and college students in this crowd. That we don't see as much anymore either, which is unfortunate, but we're working on it with all of our youth awards in the league and inviting youth speakers as well to our meetings. In the middle of this crowd is me at age 17. And just to the left of me in the plaid jacket is Richard Gott, who's now a retired astrophysicist at Princeton. I met Richard in 1960 when I was 11 years old at a meeting of the Louisville Junior Astronomical Society. He was 12 at the time. We've been best of friends since then. I was best man at his wedding. We talk every night at midnight, which may be more responsible for my voice than that root canal. Nonetheless, his name's going to come up a few times in this program, so I wanted to introduce you to him early on. Whoops. Let's try that again. Sorry. When this picture was taken in 1965, the world altitude record was just 295 miles. That's it. It was set by Alexei Leonov and Pavel Belyaev aboard the Voskhod 2, as you can see, just a few months before that convention in Milwaukee. That record was 295 miles. That's all. In just 5 years following that, we increased the world altitude record 1,000-fold. We did it, of course, with Apollo 8, which went around the moon. But a couple years after that, Apollo 13 looped around the moon and did so when the moon was at apogee. about 251,000 miles from the center of the Earth. Now over here, I have a couple of models. If you're here, it might be difficult to see in our remote audience, but I have an Earth over here and a moon here at scale. And I'm showing you the difference between the moon at perigee and the moon at apogee. It's about a 25,000 mile difference, from 226 to 251,000 miles. And on the day, tax day in 1970, when Apollo 13 did its free return trajectory around the moon, it went a little further beyond the moon than it would have if it had fallen into orbit. And it did so when the moon was here at apogee. And so that record of nearly 250,000 miles became the world altitude record. And the unfortunate news is it still is the world altitude record, low these 55 years later. We haven't beaten it yet. Okay, I don't know why it's doing that, but of course we want to increase the world altitude record considerably. Elon Musk would like us to go there and is working hard to get us there. And if we get to Mars, the question is, where will it be when we go to it? Now we know that Mars, of course, gets as close as, I don't know why this is malfunctioning. I'm having to go forward and back. I'm hitting forward here. Space or this? Okay. All right. So the question is, do we go to Mars when it's 34 million miles away, which is the closest it ever gets? Or do we try to go to it when it's 250 million miles away on the other side of the sun? Now, that seems like a rather stupid question, doesn't it? So here I have the Earth and the Moon, just a ½ inch apart, and I have Mars at closest approach. This would be the closest it ever gets, 34 million miles. Way over there on the other side of the room is Mars at 250 million miles. So which trajectory would you take? Well, most of you would say it's obvious we should just hop out and catch Mars when it comes around to opposition, but that's not the way it works. And the reason it doesn't is twofold. Number one, in order to go straight out to intercept Mars at opposition, we have to undo Earth's 67,000 mile per hour orbital velocity around the sun. And that's 2.5 times the escape velocity from the Earth itself. That takes a world of fuel to do. Worse, we also would have to drive straight out from the Earth's gravity well. We all know going straight up the side of a mountain is harder than zigzagging across the face of the mountain. And that adds a lot of fuel demand as well. So we're not going to do it that way. Instead, we're going to take a route that is not here at 34 million, or that at 250, but a 300 million mile trajectory. And it's called the Hohmann transfer orbit. The benefit is that we use the speed that that rocket has as it sits on the launch pad. It's already got that 67,000 mile per hour orbital velocity before it ever leaves the pad. So we use it. We just lift off and carry that speed slightly outward using the orbital velocity and a little kick outward to get to Mars about 9 months later. Again, that's the Hohmann transfer orbit, and it's very, very fuel efficient. And then we let Mars pull us into orbit. I don't know who decided to paint Mars in green on this, but they did. So the next question we have when we talk about distance is, what's the closest planet to us? Well, we all know Venus gets closer than Mars, 24 million miles. So that's the closest planet, right? Well, maybe not. Because if we wait a period of 5 years and I ask you what planet's been the closest planet to us, 47% of the time, the answer is going to have been Mercury. Because a lot of the time, Mars and Venus are simply on the other side of the sun or in such an angle in relation to us and the sun that they're further away than Mercury is. Mercury's average distance from us is considerably closer than Mars, as you can see, and slightly closer than Venus on average, 47% of the time. Well, what about unmanned spacecraft? We know the furthest object that humans have ever put into space is Voyager 1, and it's going to remain so in all of our lifetimes. Currently, it's 15 billion miles out. That's 5 times further than Neptune. And it's been traveling for 48 years and is not losing much speed at all now. It's so far from the sun that it is traveling at about 38,000 miles per hour and will continue to do so. So the question is, what if it were aimed at Proxima Centauri, the nearest star to the sun? What if it were headed that way? It's not. Actually, Voyager can be found in the constellation of Ophiuchus now. It's heading nowhere near the Alpha Centauri system. But if it were, how long would it take to get there? Now, it's gone 5 times further than Neptune in 48 years. So how long would it take? Almost 75,000 years. And there's not enough space on the Voyager to keep a mouse alive for 10 years, much less a human crew for that length of time, which is 12 times the length of all recorded history. We all see this in the summertime as we look toward Sagittarius, the scutum star cloud, and so forth, and we know the center of our galaxy is about 25 or 26,000 light years away. But what are you actually seeing here? And the answer is a little deceiving, because when you look at those star clouds, you're really seeing the interference of the Scutum Centaurus arm of the Milky Way. You see our sun located at the center of this diagram, and we look toward the core, but we're blocked by that intervening arm, which is about 10,000 light years away. So when you look at it, when you're looking at it, you're seeing star clouds that are about 60 quadrillion miles away. That's about 20 million times further than Neptune. And it's easy to see with the unaided eye. How big is the galaxy? I always like to carry around a 50-cent piece when I talk about the galaxy. 50-cent piece, if you can imagine the circumference of this 50-cent piece being the orbit of Neptune, the sun, the planets would be essentially virus size or slightly larger. If this were the size of the entire solar system, our Milky Way galaxy would be the size of North America and about 250 miles thick on average. It's a big place. It's a really big place. Well, we're in a group of galaxies called the local group, as you well know, and these are the first and third largest members of that group, superimposed in the same picture. They do not appear together like this, of course, but they're to scale. So you have an idea of how big Andromeda is compared to the triangular galaxy M33. The Milky Way is the number 2 sized object in that group, and here are the 6 largest galaxies in our local group, which has roughly 55 galaxies in it, most of them dwarfs. Andromeda, Milky Way, M33, a relatively unknown NGC 3109 is the 4th largest, and then we have the 2 Magellanic Clouds actually come in at 5th and 6th, which is kind of interesting. And here's a diagram, of course, of the local group with a lot of those dwarf galaxies noted. Now, it's 2.5 million light years to the Andromeda galaxy from here. And I've always tried to impress people of just how far that is, because you can see this thing with the unaided eye very easily. Well, one time I was having dinner at the Gott's house. Richard Gott's mother, when Richard would be in town over Christmas with his wife Lucy, would invite me over, and we'd have dinner over there. And one time I went to dinner over there. Now, this is a lady who was the president of the Kentucky Garden Club at one point. She had a garbage bag on the middle of her table, and that's not the normal centerpiece for her. And so she unveiled something that was apparently in response to something I had said a year earlier. I apparently said, I wish I had 1 million of something so I could show people how big a number that is. And so voila, a bowl with 1 million beads in it that were scientifically measured, plus or minus 30. And you've got to come take a look at this, and it's heavy. Now, the question you might ask yourself is, if each one of those beads in there represented a mile, how many bowls of beads would I need lined up in a line to have enough miles to get me to the Andromeda galaxy? The answer is real easy to compute. And the answer is I would need 3 billion miles, enough to get to Neptune, of bowls of these beads. 15 quintillion miles. So that's just the local group. Looking back, this is what someone in Andromeda might see at our Milky Way with its bar and its 2 Magellanic Clouds, which are quite substantial. This is an image that is likened to what we believe the Milky Way would look like, and the tilt as well, as seen from M31. Well, now we've got to figure out where this local group is. And what we see here is a promontory of galaxies that seem to emanate as a tentacle off of a large cluster. And I have a demonstration here to show you. This is a model of the Virgo supercluster. And what we have here, you can see my finger, is the Milky Way and Andromeda, just a half-inch apart here. And we have over here, looking in the direction to the right in this image, we have NGC 253 and Sculptor. It's about 11 million light years away, rather. We have NGC 5128 in Centaurus, often called Centaurus A, this red one, M81, at 12 million light years, M101 at 25, M51 at 27, it leaned a little, sorry. M104, the sombrero out here at 31, and here we have 1,500 galaxies that form the core of the Virgo cluster itself, and the kingpin in that is M87, of course, and it's a large elliptical galaxy. Here are those galaxies I just mentioned as you look up that chain toward the Virgo cluster, seen here with black dots eliminating glare from some foreground stars. And these are famous galaxies, many M objects, M86, 84, the kingpin, M87 in the lower left, and of course Markarian's chain, which is really quite spectacular in small telescopes. And your springtime observing occurs when you look toward Virgo. And that's why you see so many bright galaxies as you look from the Milky Way toward Virgo, Ursa Major, Coma, and so forth. Because you're looking up a large supercluster, which means these galaxies are going to be brighter in the sky than the ones that you're looking across voids at that may be 100 or more million light years away. This is the full moon, by the way, superimposed on the galaxies in the Virgo cluster, just so you have an idea of just how large that cluster is. If we back out to about 250 million light years, and this is a 2-dimensional representation of a 3-dimensional thing, you begin to see large voids between filaments of galaxies. The Virgo cluster is just to the left of the red dot, which is us, and you see even larger clusters beyond that, the Centaurus supercluster to be exact, and some other tentacles going down to other clusters. This is called Laniakea. This is an even larger structure. Laniakea means immeasurable heaven in Hawaiian, except, well, we have measured it, and it's 250 million light years. Maybe they have to rename it. Laniakea is seen at 500 million light years. Just one of many major superclusters like it, and you can see them kind of draped around the outside. Interestingly, all of the galaxies in our clusters are flowing towards something called the Great Attractor in Norma. And that's where the junction is in the yellow there that you see. It's a general flow that moves in that direction. The Virgo cluster's headed that way, as are we, dragging behind it. We're in the little red dot over there on the right, and you see a void beyond us to the right of the red dot. If we back away to 1 billion light years, Laniakea begins to get rather small in the upper part, and we begin to see structure in our universe. We begin to see the cosmic web itself. Who was the first person to postulate that the universe was indeed structured like this? A cosmic web with intertwined voids and intertwined tentacles of galaxies, all connected in superclusters. And the answer is a 1986 paper by my friend Richard Gott. who postulated that the universe had a sponge-like structure. That is, it would be like Swiss cheese. If you were a bug, you could eat your way all the way through the cheese, or you could fly your way through the voids all the way through the cheese. And that is, in fact, now known to be, in fact, the correct structure for our universe. Well, you as amateurs, and really many of you are so advanced that you're semi-professional in the field of astronomy. And you know that there are things you can see that are incredibly far away beyond this cosmic web, or across it, I should say. And one of those is a quasar. It's a very active galactic nucleus that lies at a distance of 2.4 billion light years. That's how far the light has traveled to get to your eye, and it's just 13th magnitude. It's easy to see in a small telescope. Just look for this little V-shaped pattern in Virgo, and there it is. And you can show this to anyone on a telescope, and you're looking over, again, a distance, a light travel distance of 2.4 billion light years. But you can do even better. This is one of my favorites, and it's easily seen in a 12-inch in Bortle 3 or 4 skies. Certainly easy to see in a 10-inch in extremely good skies. It's called PG 1634 plus 706 in Draco. And the reason I like it so much is it's easy to find, because there are 2/8 magnitude stars in the field. And when you find that, you can find this triangle with 11th, 12th, and 13th magnitude stars. And then you see a little arc of 3 14th magnitude stars. And the one marked in red is the quasar, whose light travel distance to us is 9.6 billion years. When you see it, you're stopping photons with your eye that have been traveling twice the age of the Earth. Today, because the universe continued to expand while that light was traveling to us, in whatever form that quasar has today, probably a spiral galaxy or maybe an advanced elliptical, is 13 billion light years from us today. That's called its co-moving distance. We'll talk about that in a moment. So here's what you're seeing. You're seeing light that's crossed over that tremendous cosmic web of millions of galaxies. Why do we see it? Because the black hole, it's accreting stars so fast that the radiation emanating from the core of that galaxy is just extraordinarily bright, and we're able to see it at that distance. You can do even better. I know you have a 30-inch or so up at north of here, so make yourself a nice chart. It takes a little doing, and try to locate this quasar in Lynx. It's magnitude 15, heavily reddened for good reason, because its light has traveled 12 billion years to reach us. And today it lies at 23.6 billion light years distance. And that means that today, in whatever form that galaxy has, it's receding from us because of the expansion of the universe at more than 1.5 times the speed of light. Well, of course, with the JWST, we've been trying to see further and further, and that's the whole point of that golden mirror, to be sensitive to infrared radiation so that we can detect heavily reddened galaxies at great distance. For a while, up until 2015, GNZ11 held that record at 13.39 billion years of light travel time. 2022, we found HD1, 13.46, and then last May, we found JADE's GSZ14. I'll just call it JADE's 14 for short. It's the red blotch at the lower right of that elongated blotch. The white part of it is a foreground galaxy. The redshift indicates that the light from this has been traveling to us for 13.5 billion years in a universe that's only 13.8 billion years old. So you're literally seeing something as it was near the beginning of our universe, back in a time before we thought galaxies had time to form. And this, of course, has created a bit of a challenge for astrophysicists, because we have now found some rather advanced galaxies with redshifts approaching this, and we didn't think that was possible. So it's causing some reevaluation right now by many astrophysicists as to the measurement system that we're using. But what if you were floating in space in some huge space telescope with a mile-wide mirror. And you're with a friend and you're looking at Jade Z14. And your friend looks at it and says to you, well, how far is it? Now, this is a troublesome question. It's a real problem because there are three answers. The first answer is about 1 billion light years, because that's how far away it was when it looked like that. Okay? It just took the light 13.5 billion years to get here, so we could take a picture of it. The second answer is 13.5 billion years, because, well, that's how long the light took to get here. But we also know that today it's out at 34 billion light years, because the universe continued to expand after or while the light was traveling to us. The way to think about it, and I know some of you have seen this diagram before, probably from that first program I gave remotely to you years ago, and that is the swimming pool analogy. It's not completely accurate, but it gets the point across. Looking at the top, we imagine a father has taken his daughter to teach her to swim. Now, the wall that the daughter is hanging onto is going to be Jade Z14. The father is us, and all she's got to do is swim 10 feet to get to dad. Now, when my dad did this in Lake Erie, to me, I thought he backed away all the way to Canada while I was swimming to him. But this father's just going to stand there. The trouble is, it's a magic swimming pool. The bottom continues to stretch, the walls get further apart, extra water gets sprinkled in to keep the depth up. So she starts swimming. And as she's swimming, she's not getting to dad as fast as she thought. And by the time she gets to him, she's ended up swimming 100 feet. And when she looks over her shoulder, lo and behold, that wall is 300 feet behind her. So that's Jade's Z14. 10 feet away, or 1 billion light years away, when the light left there 13.5 billion years ago, it took her with a light 13.5 billion years to swim 100 feet, or 13.5 billion light years. And by the time it did, the galaxy had receded to 34 billion light years. Well, the best way to demonstrate this, and I won't belabor this too much, but I want to emphasize something about the dynamic nature of the universe you're living in. Now, the light blue area you see here is the range from which light has had time to reach us, 13.8 billion light years. That yellow circle, that's at 14.4 billion light years from us. It's just a distance at which things are being separated from us by the speed of light because of the expansion, which means anything beyond that yellow light, the yellow line, is being separated from us at greater than the speed of light. It's not moving through space. Most galaxies are simply in space, and the space is expanding between them. Look at Z14. Light travel, 13.5 billion light years, but by the time the light got to us, it had receded out to 33, as you see here. All other galaxies are closer. And of course, most of the galaxies that we see with our deep field and so forth are further away because there's a greater volume of space with each increasing distance from us. So what if there had been a galaxy shining 13.8 billion years ago, right after the Big Bang, right after the universe became transparent to light? And the light had taken 13.8 billion years to get to us. Where would that galaxy be today? And the answer is at 46 billion light years. And that is the distance that we call the cosmic particle horizon, or more correctly, if we call it the edge of the observable universe. It's not an edge, it's not a wall, it's just a distance. But it is the location today of the furthest possible thing that we could see today. And so professional astronomers refer to it as the edge of the observable universe. And it's an important distance for that reason. Well, here is that universe. As you can see, there's a lot more beyond that. And there are other observable universes. You could be in other places. Some might overlap ours, some might not. And here's the interesting part. What if there was a galaxy that right now, today, was 15 billion light years away? and a supernova went off in that galaxy today. I guess my first question is, can we see this galaxy at 15 billion light years? You'd think not, but of course we can see Jade's Z14 that's out at 33. Yeah, we can see the galaxy that's at 15. We see its old light that's still streaming in. The question is, will we ever see something that occurs today at that distance? It's beyond that Hubble distance. It's moving, that's separating us at the speed of light. And the answer, ironically, is yes, we can, because the distance between that galaxy and our Hubble distance is not separating it greater than the speed of light. So those photons can make it inside our Hubble distance, and once they do, they can make it the rest of the way. The trouble is, our luck runs out at about 16 billion light years. At that distance, the photons can only barely make it inside our Hubble distance and make it the rest of the way eventually. And that sets another horizon, a horizon caused by the expansion of our universe. And that distance is called the cosmic event horizon. Anything occurring beyond the cosmic event horizon, we will never see if it occurs today. That means it's unreachable. Everything beyond 16 billion light years, we can't communicate with. You can fire up the Enterprise to warp 1, you're never going to get there. Now look where most of the galaxies we see in our photographs are. All those little yellow dots up there. The fact is, approximately 97% of all the galaxies that we can see today in our Hubble Deep Field are unreachable. The last photons we will ever receive from those galaxies left there long ago. You don't have to rush out to observe them. Those photons will be coming in for a while yet, old ones, but the new ones will never get here. So that's your universe. Now this is a deceiving diagram. It shows you the part of the universe that we can see out to about 46 billion light years. It dims out because we can't see beyond that, but really the light part in the middle extends far beyond the edge of that diagram. It's a huge universe. And to give you an idea of what some astronomers think about the size of the whole universe, it depends on the geometry of the universe, basically. You know that we've been studying the cosmic microwave background, trying to get a handle on whether our universe is closed and finite in size or open and infinite. And this is something that is determined by looking at the size of those temperature modelings in the cosmic microwave background. And without getting into all of that, I will just tell you that if it's open or flat, our universe is infinite and always has been. If it is closed and finite, and it could be because the Planck satellite says it's perfectly flat, which is right on the razor edge, the minimum size it could have would be 250 times larger in radius than the radius of our observable universe. Why that number? Because the Planck satellite had a margin of error of 0.4%, which is 1 part in 250. So if it were smaller than 250 times larger, and by the way, that translates to 15 million times larger in volume than the volume of our observable universe, we should be able to detect the curvature. But no astrophysicist thinks that it would be that small if it were closed and finite in size. Alan Guth thinks it would be more on the order of 300 sextillion times larger. And Andre Linde, a co-inventor of inflation theory, thinks it would be on the order of 10 to the 40,000th power times larger. You want to type that on your computer, I suggest Times New Roman 12-point type. Type a 1 and 2 miles of zeros, and you will have your number. Now, in closing, by now you're probably feeling pretty small. But you really shouldn't, because there are orders of magnitude here that may surprise you in our universe. We've talked about how large the observable universe is tonight, but we want to think about how small things get in our universe as well. There's something called the Planck length, at 10 to the minus 35 meters. That's about a quadrillionth the size of a proton. At that size, quantum uncertainty reaches 100%. Time and space become royal to the point where none of our laws of physics tell us what would go on there. If you were to try to observe something at the Planck length, you'd have to use electromagnetic radiation with a wavelength of a Planck length, and that would carry so much energy into that space, it would turn it into a little black hole, and you get nothing back. So that's a minimum size within the range of our understanding of physics. But look at the orders of magnitude in between, and what lies at the middle? What is at the median order of magnitude between the Planck length and our observable universe? And interestingly, it's dust grains floating in a sunbeam, which are the smallest thing you can see with the unaided human eye. That's the median-sized object in this range of scales in your universe. So you're really quite large, because we come in about 5 orders of magnitude larger than those dust grains, even though we spend a lot of our time cleaning them up at home. At least I do. So don't feel too small. Another prop that I meant to bring with me is a little cube of tungsten. It's a 1 cubic inch cube of tungsten. It's quite heavy. It's the same density as gold. It has 1 septillion atoms in it, which is more atoms than there are stars in the entire observable universe. And yet it's mostly empty space. Not 0.00000000006% occupied by material. And you can just hold that little cube of tungsten in your hand and point to it and say, universe, and you won't feel so small anymore. Thank you very much. Appreciate it.
Are there any questions for Chuck?
The definition of a fractal is that the structure is independent of the scale. So what struck me is as you went further and further out, we kept on seeing the same story over and over again. Do you know what the fractal dimension is of the
I'm
universe?
sorry, I couldn't hear that part.
The fractal dimension of the universe, do you know what it might be?
The fractal dimension of the universe?
Yes, it's less than 1, certainly. I've heard estimates of like 0.5 or 0.8 or something.
I don't know. I don't know. The thought is that if infinite, the density is likely to be the same as what we see everywhere, consistent. There's no proof of that. Obviously, we can't observe anything beyond those limits. These horizons, by the way, are closing in on us because the universe is expanding at a more rapid rate. The faster it expands, the harder it is for light to reach us from a given distance. So we are limited by these horizons. But I don't know of any specific reference to fractal structure, no.
Any questions online or any other questions in the room? Ron?
So if we look far enough out and everything's going fast enough and we get to the point where it's receding away at light speed, will there be objects that disappear
Yes.
from our eyes?
Yeah.
I mean, while we're watching them.
Remember all those galaxies I said, 97% of the galaxies that we see
Mm-hmm.
are already unreachable? Okay, so the last photons from those galaxies are en route to us. The ones being emitted by those galaxies now will never reach us.
Mm-hmm.
Obviously, they're still going to be flowing in over time, but over time, what will happen to those galaxies, if you waited long enough, is they'll get dimmer
Mm-hmm.
and redder, and their clocks will seem slower, dimmer, redder, slower, until they just vanish.
And are there any on that threshold?
Yes, absolutely.
Yeah.
And what the problem with observing at the threshold that you're referring to, we're talking now about galaxies like, let's say that galaxy at 15 million light years.
Mm-hmm.
Its light can make it here, but a galaxy at 17, if a supernova goes off today, that light can't ever get to us. Okay? You follow?
Yep,
what I'm
yep.
saying? Okay. But we can see Jade Z14, even though it's at 33 today,
Mm-hmm.
because it emitted light when it was much closer to us. It's still streaming in, okay? Over time, the realm of galaxies that we see will close in on us. Now, in the meantime, more galaxies will appear. As the universe ages, we'll also see additional galaxies, about 2 trillion more will pop into view, whose light hasn't had time yet to reach us.
Oh, sure.
Okay,
Okay.
so we're 13.8 billion years old. 200 million years will pass. More galaxies will appear, but the ones further away will start to disappear, and eventually if it continues to accelerate, they all will over like enough
Crazy. Thank
long
you.
enough time.
So following on his question, so those that are disappearing, are they now sort of emitting microwaves and then they'll
Yes.
it just keeps getting longer and longer until all of a sudden,
Absolutely.
okay.
Which is why we have the JWST set to observe in the infrared for that exact reason. Because we're trying to see galaxies at the maximum possible distance, which for us is the maximum possible backward view in time, which limits us, of course. The surprising thing is that some of these galaxies that we're seeing, there's some fairly well-developed spirals that we're seeing in the universe at a point in time when the redshift indicates that you should only be about 300 million years old. And that's surprising. And that's created some angst among astrophysicists as to why that would be possible. You see a lot of hysterical YouTubes that people, oh, the universe is 26 billion years old. And there was, people are just basically, it's clickbait. The scientists are looking for an explanation for how they developed that early. And they're also trying to adjust the Hubble constant a little bit, which would affect the distance measurement. As you know, there's a little turmoil there about whether it's 67 kilometers per second or 74 and so forth, and that would affect these distance measurements. There's probably about a 10% error.
All right, any last questions? All right, thank you, Chuck.
Okay, thank you.
You can. All right, so that concludes our meeting for tonight. So don't forget post-meeting meetup at Pizza Luce. That will happen. So we're actually a little ahead of schedule, so you'll have extra beer and pizza time. So that's good. Next month, June 5th, 2025, 7 p.m. right here. Featured speaker is scheduled to be Bob King. So Bob always does a great presentation for us. So we'll see you next month. And then this presentation will be edited and put on our YouTube channel in the next couple days. So thanks for coming, and we'll see you at Pizza Luce.